All right, in this simple physics class, we're just going to be looking at scalar and vector, scalar quantities and vector quantities. Scalar quantities are quantities that have only magnitude but no direction. Magnitude but no direction. And we have examples like distance, speed, temperature, mass. For example, there's no direction of mass. What is mass? Mass is the amount of the fundamental quantity that is contained in a substance. And so you can't be looking for the direction of the mass of, let's say, this marker, for example. The amount of fundamental quantity contained in the marker, whether the atom or the molecule, is the mass of it, right? And then you can't be looking at the direction of the mass. So yes, magnitude. The magnitude can be how massive it is, how heavy it is, but no direction. Why vectors are quantities that have both magnitude and direction. Both magnitude and direction. An example is displacement, velocity, force, acceleration. So if I take force, for example, when you apply a force, you are applying magnitude. You can determine the magnitude of the force applied and in what direction is the force applied. You know, either it's applied this way or it's a pull or a push. That is talking of the direction. All right. So to explain vector and scalar further, I'm going to be using distance and displacement to just give us a quick explanation of magnitude and direction. All right. Remember we said that distance is a scalar quantity and displacement is a vector quantity. So let's say this boy starts from point A here and moves to point B here. All right. It's moving from this point A to point B. And because of the obstacles, the houses, it goes like this, come down like this, move like this, then go like this, then go like this. Now came this way and then get to B. All right. So this is how he moved to get to B. And this is 2 centimeter, this is 1 centimeter, this is 1 centimeter, this is 2 centimeter, this is one, this is two, and this is three. So meters, okay, let me give it meters. So the total distance traveled by this boy is 2 plus 1 plus 1 plus 2 plus 1 plus 2 plus 3. So that's 2 plus 1, 3, 4, 6, 7, 9, 12. Distance is 12 meters. The distance between the boy, point A to point B, as moved by the ball is 12 meters. But what is the displacement of B from A? It's going to be this straight line. And now let the displacement be 6 meters, for example. So if the displacement is 6 meters, so displacement is equal to 6 meters east of south. So from A. So when you are quoting the displacement, you'll be quoting the direction. Or you say, at this point, let's call this 45 degrees. You understand? So you are going to say 6 meters on what? 135 degree or 45 degree south, 45 degree east. So you can see that the displacement and the distance, they are different. And this now leads us to finding the velocity and the speed. Because velocity is what? Velocity is displacement over time. And speed is distance over time. So if you are going to calculate the velocity of the boy from A to B and his displacement and his speed from A to B, you are still going to get two different answers. I hope with this you understand the difference between scalar and vector. Now, I want you to tell me, time, is it a scalar quantity or a vector quantity? Is time a scalar quantity or a vector quantity? Leave your answer in the comment section, and I'm going to respond to every answer to say if time is scalar or a vector quantity. Thank you, and bye bye.